All right, let's open R. I've prepared here a script for week 3. I'm going to run through it fairly quickly. You can always go back to it in the video or go online in the online course and review the code there with a little bit more explainers as well. So here I'm just going to show you how to actually apply it, how to run it in R, and what it will look like. Now, there's going to be some recap of previous weeks because there's some steps that are always involved in the analysis. So first we got to install and load packages that we need for the analysis. I showed you last week how to do that, install packages and library. So I have already installed the tidyverse suite of packages, let's say. So I don't need to install them again, I just load them here. So library, tidyverse, you should do the same. Then I'm setting the working directory to tell R where my data is located. So I give them the path to my folder or my local drive, right? I define that, and then I load the data again. This is a data frame, name of an object. So we're reading the Excel file stored in the local file under this path with the readXL function from the readXL package, and turn all of that into the object students, and the object is going to be a data frame. It's appearing up here on the right hand corner. You can click on it, check it out. This data set is about students at a university. We have different information about roughly 1,000 students studying at a university. Now, first we want to reduce the data set to only some variables we care about, right? We want to exclude columns, basically. We don't need the full data set. There are in total 23 variables, as you can see here. Right, as a quick recap, we could also look at the data set again using the structure function. If we run that, we get an overview down here, and you see these are all the variables in there. But at the moment, we don't care about them. We just want to deal with a few of them in our analysis. So how do we do that? To do that, we're going to use the select function. The select function is part of the dplyr package, and the dplyr package is part of the tidyverse suite of packages, right? So we're going to define a new data frame called report, and in that report, we're going to put the students data set, and then, remember this piping operator, it's called a pipe operator. It just means first do this and then do the next thing, right? So we're gonna put the students data frame into the report data frame. And then we're gonna use the select function and only select these 3 variables or columns, right? So if we run that, you'll see there's a new data frame with 1,000 observations, so the same number of rows. However, there's only 3 more variables left. If we click on it and check it out, we see, okay, we only have sex, faculty, and term. So the sex of the students, what faculty they're enrolled in, and the term, right? How long they've been studying. So this is how you select only certain columns in your data set. It can make things easier and cleaner, especially in larger projects. Now let's move on to actually getting rid of rows, right? We have 1,000 students here, but sometimes you need to limit your analysis to only a few of them. So for example, here, I want to exclude all the students that have studied less or equal to 6 terms at the university. And I also want to limit it to students that are studying at the political science and sociology faculty, right? So I'm doing this with the filter function. The filter function is also part of the dplyr package. The dplyr double colon is just to refer to the particular package that the function is under. In most cases, you actually don't need to write that. I just write it for completeness. And sometimes R gives you an error message when there's a violation, because some of the functions from different packages may have the same name, and that causes issues. So sometimes it makes sense to actually indicate the package that you're using. All right, different terms basically within the filter brackets are always divided by commas. There's also one new operator here, which is this in sign, percentage in percentage, which basically says take the faculty variable and within it only, only take the political science, values that correspond to political science, and values that correspond to sociology. And you do that with the C open brackets, which always tells data to look for the certain values, a list of values defined in here, right? It's also called a vector. All right, so let's run that. And we see, whoa, the report data frame is reduced to only 330 observations. And here in the faculty, we only have values for political science and values for sociology. All right, and if we actually, as a quick recap, wanted to get sort of the distribution now of two variables, compare them maybe, we can use, again, the library janitor command, so function janitor package reloaded, and we use the table function that I introduced last week to produce a little overview here, and we see actually 62% of political science students are female, 48% of students enrolled in sociology are male, right? This is just a quick repetition from last week. All right, now let's also talk briefly about sorting rows, right? So if you have, for example, here, male, female, female, male, the observations are just ordered in no particular order, right? They just appear as they appeared in the data set. Same with the term, you have 0, 2, 1, 14. There's no sort of meaningful order in which they are displayed. You can change that using the arrange function. So let's save the report data frame in a version that is sorted, right? So again, we type report, which is a new object, but it just overrides the old object report. And then, pipe operator, we use the arrange functions on term. So this is basically sorting the term variable. Let's run that. And you see now the data set is sorted based on term, starting with 0, 1, and so forth. Now, what about if you want to change the order of columns, right? Because sometimes you may add some new data to your data set and you have new columns appearing way down the line, and you actually want to bring them to the front to compare them more directly, either visually or because well, you want to bring more order to your data set. So you can do that also using the select function. Actually, the order in which you enter variables into the select function here is going to determine the order in which they appear in the data set. So let's change the order. Currently we have sex, faculty, term. We're going to change the order by just changing the list of variables, faculty, sex, term. If we run that, go back to the data frame, we see now faculty is first. Now, if you just want to pull one variable to the front, let's go back to our students data set, because there we had a lot more variables, and we actually just want to put one of the variables up front, and we don't want to type in every variable in the right order that we have, right? So for this, we can use a shortcut called the everything function. So we use the students data frame, we override it with the students data frame, right? Then we use the select function, and we want to have faculty and sex first, two variables up first, and then everything else. So we use the everything function with empty brackets, right? Let's run that. We go to the students, and we see faculty and sex are now appearing first. Right. What about if you want to only kick out certain variables? In the previous example, we only kept certain variables that we were interested in. What if you want to keep all the variables except for one or two, right? You can do that with the minus sign in the select function. So again, we use students data set, we update the students data set by overriding it, and then we select everything, all the variables that exist, except for the minus sign, the working class variable. And we see now we have one variable less here, 22 variables. All right, let's move on to changing data types. And this is very crucial in R and can get quite annoying, because often you want to do something in R, run some analysis, or later on maybe even a regression or a table, And R gives you an error, it's not really clear why. And often is the case that just the type of variable, the class of the object is wrong. And you need to convert it, right? So I'll give you an example here. Let's look at life satisfaction of students. Okay, the life satisfaction variable is called lifesat. We've learned actually how to look at it, so let's do it quickly. We can use the table function, look at lifesat in the student's data frame. So again, data frame, $ refers to the column, and then lifesat. And we see, wow, there's a lot of values here, okay? This is the frequency of all the values, but that's not what we want. We don't want a table of every value that exists, right? It's not a categorical variable. It seems to be sort of a numerical variable. So what we'd rather want is a mean. So we can try that. We know one command that can do that, which is the summary command from last week. And we choose this variable. And actually it doesn't work. It just gives you the length of the variable and that it's a character variable. Okay, so means don't work. Let's try it another way. I'm going to introduce to you the mean function within the tidyverse approach. So we take the dataset students and then we take the mean function of lifeset. This should give you the mean life satisfaction of students, right? Notice here that rather than using the base R approach, which is listing the data set, the data frame, and referring within the data frame, the $ to a specific column, here we're actually first telling R, take the data frame, and then R is always working with the assumption that you're working on this particular data frame, and then we pipe it with the pipe operator. So, and then we take the mean of the life satisfaction variable, because R already knows that we're referring to the student's data set, right? So no $ needed here. So let's try that, and actually we get an error message down here, warning message. Argument is not numeric or logical, returning NA, not available, missing values. All right, so that means we got to change the variable. We actually got to tell R that this is a numeric number variable and not a character variable that is text, right? So even though the numbers appear to us on the screen as actually numbers, R doesn't realize they're numbers. R thinks they're text, right? Because they're defined as a character variable. All right. So let's do that using the mutate function. So we override students, and then we take the mutate function, and we define a new variable, which is called lifeset. So it has the same name as the previous variable. And that new variable equals to the old variable lifeset, however, converted to numeric. And this is the function s.numeric. So if you want to convert a variable that is not numeric, you can use the s_numeric function to turn it into numeric 1. And we're going to save that new converted variable in a new variable, and that's where you use the mutate function. Okay, so let's run that. Actually, if we do look at the dataset again, and we look at life satisfaction, we now see it's called DBL, which stands for double, which is a type of numeric format, which quickly explained that last week as well. All right, the mutate function is incredibly powerful. It will help you to convert anything or to change anything in your data set, create new variables, change variables, rename variables, whatever you'd like. For example, there's a variable in there called COB, which stands for country of birth. Well, maybe we want to just change the name of that variable because it's not really intuitive, right? We don't know what it stands for. So then we're going to use the mutate function here. Mutate new variable country, we're going to call it country, equals COB. Okay, so let's run that. If you go to the student's data set, we realize now, again, there's 23, and there's a new variable here called country, which is the same as the COB variable here, except that the name changed, right? I always recommend keeping original variables, not deleting them, but you could also now delete it if you wanted to. You've learned how to do that. So you can use mutate also to rename variables and to create new variables, right? Now, it gets a little bit more tricky, but it's very important. Often in data cleaning, you actually want to change not the type of column or the name of the column or the number of rows. You want to change the particular values inside the data frame, right? So for example, if we go to the students data set, right, we have here the rows, here the column, and inside the cells are the values. And let's imagine we want to change particular values inside this data sheet, okay? So in this case, let's change UK to United Kingdom, all right? We have here in this new country variable, actually, we have some values for UK, okay? We have a bunch of students who were born in the UK. But for whatever reason, maybe we want to look at it later in the graph, we wanted to spell it out as United Kingdom. So how do you do that? Let's first look at it with the table function to get sort of the frequencies, and we see, all right, there are actually 75 students here from born in the UK. Now, I'm going to introduce a new function which is called case_when. The case_when function I'm going to use a lot. We're going to be using this a lot in this course. It changes values based on particular conditions, right? So it changes a value only when certain conditions are met. You know, if you know stata, that's usually done through if conditions. If this and this, then replace that and that. Okay, this is the same here, case_when. So we change the student's data set, we override it, and we mutate, and we manipulate the country variable equal to, and now we enter the condition. So case_when is the function. When the old variable COB equals, and notice here 2 equal signs within the case_when function, 2 equal signs UK, then let's call it tilde, turn it into United Kingdom, comma, if true, if it is basically not the UK, then turn the variable country into country, which just means that leave it as it is, right? Don't change it. So the case_when function always lets you define a certain criteria and then in the end define what R needs to do in case that criteria isn't met, right? Remember, if you want to check it out a little closer, you have the help function here, question mark, case_when. All right, and you can look at the help file and see how this function works and what it needs. And you can also check out some examples down here, all right? So with this case_when function, you can literally change anything in the data that you'd like. So here I'm changing UK value in COV to United Kingdom, all right? Let's run it. Okay, and if I now table this again, I see it's not UK anymore, it's United Kingdom. All right, let's take another example and look at the term variable, right? How long have students studied? We're going to look at that variable, and actually you have 0 to a bunch of numbers here. These are the term times, and this is how many students have studied this long. Well, the problem is it's not really sorted. It looks kind of strange. You have 0, then 1, 10, 11, 12. That gives an indication, well, R probably doesn't know it's a number because it's not displaying it correctly, right? Let's check it out with the class function, see what this term is. Well, yeah, it's right. It's actually a character variable. So we can't really calculate with it, right? You can't calculate with text. So we want to change the term values to start at 1 and not at 0, actually. And we want to give it a new name. And first, we want to convert it to a numeric data type. All right. So let's do that. You can do both in one. You override students, and then you mutate, and you define a new variable called term1. And term1 is basically the numeric version, the numeric conversion of the term variable, which is currently character, But to those values, you add 1, okay, which means it's not, the term's not starting at 0 anymore, but 0 plus 1 is 1. So let's do that. And then actually do a summary of the variable, which we've learned earlier how to do that. And we see, okay, the minimum value is 1, the maximum value is 15. On average, students have studied 8 terms, basically 4 years in the German context. Okay, we can also quickly check whether our recoding was correct, our changes in the term variable were correct. So you can do that also using the table function and creating a very quick cross tabulation of the frequencies, and you do that with the table function, term variable, and comma, the second variable, which is now the new variable term 1. Okay, table is the base R function, and that's why we are using the data frame and the $sign to refer to columns within data frames, right? Okay, and here is actually a cross tab. This is the new variable of term, the numeric one, and this is the old one. And we see here 0 refers now to 1, 1 to 2, 10 actually refers to 11. And this way we can actually check whether what we've done, our conversion was correct. And it looks like it was. Okay, so let's look at the summary again, and let's check out the class. And now it actually is numeric. All right. So here's a new example. We want to change the age variable, actually. We want to create a category for age, because currently, I mean, let's look at age here, see what it looks like. It actually has, you know, the students are a minimum 10 years up to 80 years. Of course, this is not a real example. This is all fake data. So let's ignore the fact that this is highly unlikely. But on average, students are 25 years old, almost 26, 25.9, right? We actually don't want the age of all the students. We want categories. We want to know in what type of categories they fall in, right? And we're going to define 3 categories here. We're going to define students over 18 and under 25, and then over 25 to 30, and then students over 30. You're going to define these 3 categories and create a new variable. So we're going to do this using the mutate function and the case when function, all right, that I've introduced previously. Okay, so override the students data set, right? Basically load students data set, tell R that we are dealing with that one. Then pipe operator, mutate, so change something, create a new variable called age underscore category, and that variable is 1 in cases that age is larger or equal to 18 and age is smaller or equal to 25. Then this new variable is 1, right? Tilde 1. It is 2 when the age is larger than 25 but smaller than 30, and it is 3 when the age is higher than 30, right? So you do this separating it out, the conditions by a column. So if none of these conditions hold, right? If none of them apply, if somebody's, for example, below 18 or has no value, then this is the true. Then we define them as missing values, not available values, and this is done by the na underscore real underscore sign here in R. Okay, so let's run that. Check out the students data set again, and there should be now a new variable exactly here, age category. Now we've already manipulated some variables, changed them, recoded them, we created new variables, all of it using the mutate function and then different additional functions like as numeric or case when, right? And there are lots of variations of those. They are very broadly applicable to any type of problems you may have with your data set. Now, we've done this in several steps now, but actually R offers a way to do this quite efficiently all in one go. using the pipe operator. And this is what I'm going to show you now. If we go to R here, I already prepared the code for you. So again, we want to override the student's data frame with itself, but we take the student's data set and then mutate a bunch of things, right? So we're going to do this all in one step. First, we're going to create the live set variable and we convert it to numeric. Then we're going to create a new variable called country, which is the same as country of birth, the old variable. So we're just changing the name there really. Then we're actually replacing the United Kingdom with we're replacing UK and spelled out United Kingdom. We've done all this in above, but now we're doing it all in one go, separating it out with commas within the mutate function. Okay. We're also going to change the term variable, add a number here, and we're going to create a new variable called age category that complies with certain conditions we're defining. We're doing this all at once within the mutate function, right? Never forget to actually have the closing parentheses. So any open parentheses needs a closed parentheses, otherwise you get an error message. So you can highlight all of that and run it, and that's it. So all the steps we've done before, step by step, you actually can be more efficient with how you write your code and combining it just in one, all right?